What's up, guys? I dropped my little post-it notes. Hey Devs is back with some more LeetCode. I felt like doing some linked lists today. I went through a bunch of problems in the problem list, and most of these I just didn't feel comfortable doing. Like, I would try to write up a solution, test it, see if it worked, and then I would get a runtime error, or like I went out of the time constraints, and then I would look at the solution. Then I would learn the solution, and then I'd feel like I shouldn't implement that solution because it wasn't my solution. At least not posting on YouTube. I mean, of course, it's very useful to learn from others, but you want to challenge your brain a little bit. I have a pretty good understanding of linked list. I programmed a lot of them in my computer science 2 class, and it was over C++, and we built a lot of lists. We went over lists, queues, stacks, and DQs. We went over and binary trees. So it was a lot about pointers and a lot about nodes and pointing to different nodes. So I thought these two were fairly simple. The remove duplicates was definitely the easier problem. The merge two sorted lists actually gave me a little bit of trouble, and I thought my solution was bugged. Like, I was like, why am I getting this and not this? But I ended up using a if statement instead of a while loop. Of course, that wouldn't work. I thought that was kind of dumb of me. But we all have brain farts every now and then, so another episode of doing LeetCode every day until I get a job. Looking at some of these problems, they're pretty tough. You need to know a good bit of algorithms. You need to know a good bit about the language you're using. You need to know a good bit about the libraries that you can use in the language. So we might have to slow down later on how many we do. I might have to start doing one every few days, or I might still try to do one a day, but it will have to be like an easy problem, and maybe we can do like a medium once a week. Tomorrow I'm off, so I'm going to try to do a harder problem. Today I got home from work around like 4:30, talked to my brother till 5:30, kind of chilled on the couch and ate a little bit. And I've spent the past hour kind of searching LeetCode and trying to find problems that I could record about. At least decently easy problems that wouldn't spend like 40 minutes doing. And the linked list problems ended up being the ones I felt the most comfortable with right now. There's a few of them I would say I could solve, but I just didn't, because I just one, the explanations would kind of be poor, and two, they were harder problems that take me a while. Ooh, my chair almost broke. Alright, anyways, we're going to start with the remove duplicates from sorted lists. If you don't know too much about linked list, I'm not going to explain it too much, but this is the class they give us. It holds a integer, the value, and then another list node. So if you follow the list node to the very end, then you will go through the entire list. Usually you would implement a list that holds the value of the first one, and then from that first one you can follow along to the end. The reason you would want to use a linked list is because of fast insertion times, fast deletion times, and because unlike an array, you have to allocate the memory, and then if you want to add one more value to an array, you have to copy an array over. I mean, that takes O(n) of time, versus a linked list, you just have to create one new node, add the value, and then link them together. So that's kind of a little bit about linked lists. But we can go straight into the problem. So given a head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. So as you can see here, this one has 1, 1, 2, and then we want to return the first node, and then that way they can fall around to 1, 2. And same for the second example, you get 1, 1, 2, 3, 3. You just want to return 1, 2, 3. So we want to keep track of the first node, so we can do list node we can give a temp variable and then equal it to head, and we'll return the head, right? So head's going to keep the first value no matter what, and then temp is going to be the one we use to manipulate the list, of course. So we want to do while temp is not equal null, and then we want to do temp is equal to temp.next. So what this is doing right now, this little while structure, is it is going through the entire list. So we can do a system.out.print line to go ahead and show that. And we can do just temp.val. Wrong answer. So you can see it does loop through the entire list. Head is 112 and then output's 112. So this little structure right here will loop through the entire list. And what we want to do is see if the temp.val is equal to temp.next. Val. Actually, we want to make sure it's not null. And since we're checking the next list node, we want to make sure the next list node is also not null, or we'll get I think it's a null pointer error. So temp.next does not equal null as well. So after we check that, we can see that if the temp.value is equal to temp.next value, we want to set the temp.next equal to temp.next. So what this is saying is, given the first example, temp.null, which is the first node right here, we see that it's not null. We'll check the next value to see if it's null. That is also not null. So then we go into our while loop. If temp.val is equal to the next list node.val, we can see that the temp.val is 1 and the temp next.val would be 1 as well. We want to set temp.next equal to temp.next.next. So what this does is it removes this link and goes ahead and links 1 to 2. And when we break out, we'll go to temp.next. That's actually not what we want to do. We want to check 1 again to make sure. So you could imagine, or actually we can I'll show you this. So temp is equal to temp.next. And if we try this code, it should work. Of course, we got to put the semicolon and not do an equivalence logical operator. You see it works for these two test cases, but if we go ahead and add a new test case, and given if we add 3 ones and test that one out, it will actually fail. Yeah. So we still have 2 ones in there, and this is what happened during my first solution, and I kind of looked at it and I was like, why is that 1 there? Because what we're doing here is we're removing temp.next. We're removing the link. If you can imagine, there's, well, I'll type it out. So there's 1 points to 1, and then that points to 1, and then that points to 2. If we take 1 and we see that like during the first example, we link 1 to 2 and remove this node completely, and then down here, it's 1 is pointed to 2. What this is saying is we're gonna skip the 1 and then go straight through it, and then point to the 1 as well, and this points to 2. So during the first iteration, it does get rid of the first node that's equivalent, but this temp equals temp.next, the temp will not point to the first one anymore, it'll point to the second one. So if you imagine, this is what our new linked list looks like after the first iteration, getting rid of the first node. But instead of our temp pointing to this node, it actually points to this node, and it's not checking the equivalence of the two ones again. And it's an easy fix. So if the values are not equal, we want to increment the pointer, or increment the list by 1. So we just put an else statement because we don't want to increment it if we remove a list, because the next value might actually be the same value that we just removed. And we want to check that as well. So this should be a working solution. There we go. And we go ahead and submit this one. And it's 0 milliseconds beats 100%. So yeah, it just goes through this while statement, kind of loops through the list. If the current value of the node you're at and the next value is the same, it will link the first node to the node after the similar value. And then if they're not the same, it will go ahead and move to the next node and then check that one's equivalence to the next node. Linked lists are kind of confusing, but once you get them down, they're not horribly bad. And we'll go on to number 21. This one's a similar problem because they both have the same list node structure. It's the same class we're working with, so it should be not fairly similar, but it should feel familiar. And this is problem 21, merge two sorted lists. You're given a heads of two sorted linked lists, list 1 and list 2. Merge the two lists in one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So this one is fairly similar. We want the list node, and we want to have a temp, and we want to have a solution value. The reason we want to have a solution value is because, or the reason we want to have two list nodes is because we are also going to be incrementing the list 1 and the list 2 values, so we want to be sure to keep track with the first node of our new linked list. That's what solution is going to keep up with, and temp is going to go through and check these values and kind of combine the links together, while list 1 and list 2 are also going through their own list. So all three, temp, list 1, and list 2, will not be the heads of the list. They will go through the list and kind of be like iterators. So we want to set a solution equal to temp, and that needs to be equal to a new list node, and we will pass it no values. That will automatically set value to 0 and set the list node next to null. And we want to return the solution dot next. The reason we want to do that is because the first node is kind of a dummy value. It doesn't hold anything for us, and if we get past two empty lists, like in example 2, we will go ahead and return a empty, or if we get past two null pointers, not null pointers, there'd be null objects. If list 1 and list 2 are null and they're not an actual, if the reference variables are null and they don't actually point to an object, then we will also return a null. Now that we have our solutions returned and we have our temp and our solution list nodes, we can go ahead and make a while loop. During my first solution, I put if here instead, and I sat here forever looking crazy. But list 1, we want to make sure list 1 and list 2 does not equal null, right? And list 2 does not equal null. The reason for this is because we want to compare the values in list 1 and list 2, And if one of them are null, we won't be able to make the comparison. And this will also lead, this will traverse the list until we reach the end of one of them. And then if we reach the end of one of them, we know that our list that we've created is sorted so far, and every value left in the other list would come after our list. So what I mean by that is that we can check if list 1 is equal to null. And if list 1 is the one that ended up being null, we can do temp.next is equal to list 2, and then else. That would mean list 2 ended up being null, so we can do temp.next is equal to list 1. So this would get in the case of example 3, list 1 gets inputted as null already, so the while loop will never be entered, and this checks to make sure, checks to see which list ended up being null, and list 1 is the null one, so it sets temp.next equal to list 2, and then we have our dummy node pointing to the list 2 right now, and then we return the next, from our dummy node we return the head of our actual sorted linked list. And if we run this right now, it should give us a check mark for example 2 and example 3. Time limit is not equal null, that is not equal null. Last expected input. Hold up just a second. New list node, while list 1 does not equal null, and list 2 does not equal null. Oh, this is an infinite loop. Well, we can go ahead and break out of this, because in the solution, one of them will always end up being null and breaking out of the list. And then we can see here that for number 2, list 1 and list 2 are both equal to null, so the solution.next points to a null, aka giving us the correct answer. And in this one, we see that list 1 equals to null, so that will be checked in this if statement, seeing that list 1 is null. And then temp.next will be equal to list 2. We return the next variable, so which would just be list 2, and that's what we want to output is list 2. And now all we have to do is write the logic to sort the values if they're we want to sort the values in list 1 and list 2. And the way you do that is to use temp. We want to set temp equal to temp.next. So we're constantly going through our, if you can imagine the 3 pictures we are given to the left, this is list 1, this is list 2, and this would eventually be our temp list or our solution list, and temp is iterating over this as we add nodes to it. And if list 1 is not null and list 2 is not null, we can go ahead and check if the list 1.value, because if they're not null, they are holding some value, right? So we can see if list 1.value is less than list 2.value. And if list 1's value is less than list 2's, we want to add that value into our solution list, right? So we can do temp.next is equal to list 1. And what that's saying is the first node of list 1, or the node that we're looking at, is equal to the next value in our sorted list, right? And since we already have that value in our sorted list, we can go ahead and set list 1 equal to list.next. So when the next time we go through the while loop, it will check the next value. So for the first example, when this code executes, we'll now be looking at 2 or 4. and it will check those values instead of checking one over and over again, right? And then on the else, that means that list 2 value is greater than, list 2's value is less than or equal to list 1's. So we want to do something very similar, but just replace list 1 with list 2. I'm going to do temp.next is equal to list 2. And then list 2 is equal to list 2.next. I just forgot the 1 here. And this should be a valid solution to the problem. Let's make sure I don't have no errors. Of course I have errors. I don't know why I forgot the semicolons. I think I was just talking and not thinking about the code too much. Yeah. So what this is doing is the first check, we create a temp and a solution node. We set solution and temp equal to a new node, so they're pointing to the same object in the heap. And then next we'll check the 2 list nodes that we got handed would be the 2 list over here to the left, as you can see. It would be these two lists right here. We'll make sure they're not null, because in example 1 or example 2 and 3 we were past null list, right? And we'll go through this body as long as there is a value to check between both of them, right? So first we'll check the first value in list 1, which is 1, and then we'll check the first value in list 2, which is also 1. We see that 1 is not less than 1, but 1 is equal to, but list 2's val is 1, and list 2's val is less than or equal to list 1. So it actually won't compute this block of code, it'll compute this block of code first. And it sets, right now we have a dummy node, and we want everything after this, the dummy node, to be the solution, right? Sorry. So temp.next, we set the first node of our sorted list equal to list 2, and what that does is it copies this list and kind of places it right here till further notice. List 2 does not point to 1 anymore, it points to 3. And the first list 1 is still pointing to 1. Then we set temp equal to temp.next. So this statement right here, we set temp.next equal to list 2. Temp.next will now not replace the node we just acquired. It will, the temp.next, it's kind of hard. So temp.next currently would be null. Not null, it would be the next value in list 2, but we don't really care about that value too much. We want the next sorted value, right? So in this case it would be 1. So we go back through the list. List 1 is not null because the current values would be 1, 2, and 4. List 2 isn't null because the current values is 3 and 4. And then we check if list 1's val is less than list 2's val. 1 is less than 3 in this scenario on the second pass of this while loop. Temp.next is equal to list 1. So we want to set the, so right now temp is right here, so we want to set the next pointer equal to the first node in list 1, which would be 1. Then we can set list 1 equal to list 1.next. So now list 1 is holding 2 and then 4, and list 2 is holding 3 and then 4. And our current temp list would be 1 and then 1. And then whatever it's pointing to after doesn't really matter because we are going to rearrange it anyways. So for the sake of this problem, we can say it's pointing to null. The third pass would check 2 against 3. 2 is less than 3, so temp.next, which would be this 1 pointer, would point to the second value in list 1, which is 2. And then we'll go ahead and increment list 1's node by 1, giving us the final node 4, and we want to check 4 against 3. 3 is less than 4, so we will actually execute this block of code, and so on and so forth until we get the sorted list. This video really isn't about explaining linked list, but explaining how I came up with my solution. So if you understand linked list, this solution should make sense to you. If you don't understand linked list, I suggest you watch another video that is actually someone explaining linked lists conceptually and have nice visuals and nice animations so you can grasp the concept a little more. And it never hurts to write your own linked list to understand how the pointers point to each other, how to rearrange node pointers, and how to iterate through a linked list. With these solutions, let's go ahead and submit it to make sure it's right. So we got 0 millisecond time for both of them. So I think it's fairly nice. A little linked list manipulation is always fun. I might try to do another linked list problem. In the problem list, you can filter by topics. So all I did to find these problems was I just search up linked list. And then we did the merge to sorted list or remove duplicates from sorted list. And there's a second version of this. Given head of a sorted list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. Okay. That's interesting. So if it has a duplicate, we want to remove the number completely. And they're in ascending order. This would be a cool one to do next video. We might try to do this one tomorrow since I'm already kind of on a linked list roll. I'm off of work tomorrow. I don't have school tomorrow. So I might try to go ahead and solve more than one to kind of prep for the next few days when I do have school and work and I don't have as much time to sit here and think about LeetCode problems. Because a good chunk of my time today was focused on finding LeetCode problems I wanted to solve for a video. I could have been able to solve one without recording it, like a harder problem, but I wouldn't be able to explain it that well. I still didn't explain these the best, but to the best of my ability, I tried to, and so I might go ahead and try this one. It would probably be, here we can go ahead and look at our remove duplicate. It would be similar to this solution, but if temp.val is equal to temp.nextVal, we want to remove it completely. Okay, I might think about this one tomorrow and maybe go over a few more linked list problems. But there's a lot of them. Reverse linked list too. What is this one? Given the head of a singly linked list, 2 integers left and right, where left is less than right, reverse the nodes of the list from position left to position right to return the reverse linked list. Okay, so given 2 and then 4, they want us to switch the order around completely. Okay. That one might be a little bit more challenging. It's another medium problem. Since I'm off tomorrow, I might try to tackle a hard problem with the reverse nodes in K-group. Given head of linked list, reverse the nodes of list K at a time and return the modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is not a multiple of K, then left out nodes in the end should remain as it is. You may not alter the values. Let me try to see if I understand this problem. Anyways, I might try to do a hard problem tomorrow or another, or do a medium problem, because those take a little bit more to explain. But I thought the 2 easy list problems I did would be nice, because I know a good bit about linked lists. or we might try to do something tomorrow that I have no idea what I'm talking about, and so I can learn something new. Of course, it's always good to learn something new. I thought these problems were fairly challenging, especially with the constraints. I never had to remove duplicates out of the linked list I've created, or merge two linked lists. I've never had to do that and keep this sorted order. So those were fun to think about and solve. But I think that's gonna be all for today's video. I hope you all stay blessed. Have a great day, and I will see y'all guys tomorrow.